Hey guys, we did the flat iron problem of the building and the area of that building in class. And then we reviewed some things about midpoint and distance. We also reviewed that we will be doing questions out of the textbook and workbook, and that the pre-AP are like thinking tasks that we'll be using. So today's the first day we're working out of here, and we've been talking about midpoint and distance in general. And so now we're seeing how is the textbook and how can we work some problems with this. So we already worked question number 9, so you should have this done. If you don't, you should get notes from another student. And depending on the class, we may have worked 15 and or 12. So I didn't work this one in every class, so let's go ahead and work out question number 12. Now, because I sent everybody home with graph paper, so you should use some graph paper. I'm just going to put a little piece of graph paper here so I can work out this question. Okay, so question number 12 says, suppose that P and Q have one endpoint and that P is at 0, 0. All right, so we're going to graph that. They tell us that the midpoint of this line, somehow the midpoint of this line is at 2, 5. So I want enough room so that I can have room for Q. So I'm going to set the X and Y axis here. I can put it wherever I want. I'm the boss. But it says point P is at 0, 0. Okay. Now it says the midpoint is at 2. So I'm going to go over 2 and then up 5. So the midpoint is at 2, 5. So if I think about this, the line that's not the line. That's only half of the line. Because if I think about this, the line has to keep on going here, right? Because that dot is just the midpoint. So my students that thought about this in class, we discussed this idea of our slope triangle. We went up 5 over 2 to get to this point. And now we're just going to do that again, up 5 over 2. And we should arrive at the endpoint we're looking for, right? So we believe that this point there should be point Q, because if the middle was 2, 5, then the endpoint should be 4, 10. And hopefully that kind of makes sense with that pattern. So the middle is here. The rest of the way has to be somewhere there. So this is point PQ. And the middle is there. And that is what they're saying in the problem. So what is Q? We're going to say 410. Why? Because I graphed it. Okay. What else? It says, how would you find Q if this was not quarter of the way there, or excuse me, not a half of the way there like in the last problem, midpoint would be half of the way there, but rather a quarter of the way there. So if this was 1/4 of the way there, meaning I had 1, 2, 3 more quarters, another quarter, and another quarter left to go. This is a thinking task, isn't it? So students were thinking, well, I think if I go up 5 over 2, up 5 over 2, up another 5 over 2, up another 5 over 2, I guess Q has to be way up here. Up 5 over 2, up another 5 over 2, up another 5 over 2, up another 5 over 2, and finally you're there. That would mean that this is a quarter of the way there, and the rest would be the remaining 3/4 of the way there. Okay, so what would be this? If this was the new point of Q, the new point of view would be, instead of 4, it would be 1, 2, 4, 6, 8. And instead of 10 here, I'd go 5, 10, 15, 20. Okay. Now, how do I know? Why do I know? I graphed it. Okay, question 15. When I think about this, I think about graphing. It says there's an endpoint, RS, something segment RS. We know the coordinate of the first point and the coordinate of the second point. Complete each statement using a fraction. All right, so this means left, right? And that means up. This means right, and that means down. So I have to be prepared wherever I put the origin to move left and up, and then I also have to move right and down. So I kind of need to put my origin in the middle, somewhere in the middle. I think that's just fine, so that I have room. All right, so I'm going to have to go left 4, up 3, and to find my point R, left 4, up 3. Then S is right 8. So I might even have to go a little further than I thought. Right 8. 1, 2, 3, 4, 5, 6, 7, 8. Right 8. Down 5. Boom. S is right 8, down 5. Now, using a straight edge, I'm going to connect these points. And I didn't do a very good job, so I'm going to try again. And I notice a couple of things. It says point -1, 1 is what of the distance of the way there. So let's find that point, -1, 1. -1, +1 is along that line. And it looks like I see a slope triangle. It looks like it went down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. I see my slope triangles. And so this also helps me with the feet of saying, it looks like that's a quarter of the way there, not half of the way there. If that was half, this is half of a half, which is a quarter of the way there. Now let's take a look at this point. So I'll use a different color. 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. They're talking about this point right here. That looks like that'd be 3/4 of the way there. How did I know? I graphed it. So we always want to say why. Because if we use our notes and we forget to say why, and when we use our notes on the test, we don't know why, and we can't use our notes for anything. They're not worth anything. They don't work. Okay? All right, so we finished the front. Now we said, oh, we got to do the back too. But for some of us, we have the long weekend. If you didn't get all these done between now and Friday, you can finish them up over the weekend. So let's take a look. We did question 17 in class. We said from B to A. So instead of normally we start on A to B, we read left to right. They said start at B and work to A. We came up with half of the way there and half of the way there. We came up with this coordinate right over there, which was 8, 2. That's a 2, right? So let's look at the questions we didn't get to, right? It says the 0.3 over 10 of the way there from A to B. So they'd like me to cut this in 10 equal pieces. Let's see if I can. I look at my slope triangle. These are not landing right on my box. So it's not as easy to do, but let's see. In the X, I went from 12 to -4. That means I went back 4 over 12. That's a total of 4 and another 12. That means I've gone 16 in the X direction. Let's see how far I've gone in the Y direction. I went down here to -7 and up all the way to 5. So that's 12. So what would be 3/10 of the way there? Well, I cut it in half, didn't I? And so that would mean I would need to cut this in 5 equal pieces, which is not easy. It's not, how do you cut 16 in 10 equal pieces? You get 1.5. And you cut 12 in 10 equal pieces, you get 1.5. So I'm not going to land right on the grid lines. I'm just not. So I'm going to have to add 5 tick marks in between here, something like that. It's not pretty, but 1, 2, 3, 4, 5. Yeah, and it's not making it all the way there because of that. All right, and then 1, 2, 3, 4, and I make it to way 5. So they've asked me to go 3/10 of the way there. So 1, 2, 3/10 of the way there. I'm getting right about there. So it looks like about the coordinate, maybe a little, about 1/2, and down about 3.5. But that's not exact, but that's approximate. And I'm going to leave it at that for now. At this point in the lesson, I'll leave it. Now it says point B is 1/3 of the way there from A to C. All right, so I'm going to restart this, because now they want to say point C must be over here because B is 1/3 of the way there, saying this is 1/3 of the way there. So we went up 12 over 16, and that's 1/3 of the way there. So I want to go up 12 again, over 16 again, and one more time. I run out of room there. So I'll make a quick sketch here. If this is 1/3 of the way there, and I went up 12 over 16, then to get the rest of the way there, I got to go up 12 over 16, up 12 over 16. Right? But notice I don't start here at 0, 0. I'm starting at -4, 7. So from this point, that is 1/3 of the way there, I'm already at 12, 5. So I want to go up another 2 12s. So the coordinate is 12, 5. And in the y, I want to go up 2 more 12s. So up 2 more 12s. And in the x, I want to go up over 2 more 16s. And this should tell me the coordinate I'm at, which is what they want. So I think I get 44. What do I get here? 24, so 29. And there's my answer. This should be 44, 29, because I've added 12 each time from -7. And from -4, I've added 16 each time for 1/3. Okay, enough of those are called partitions. Now we're going to use the midpoint theorem. And our midpoint formula, we just add the 2 x's and divide by 2, just like we would on our hand. Add the 2 y's and divide by 2. So our 2 x values, we add them and divide by 2. That creates our x coordinate. And then our 2 y values. So as we look at this, our numerator is 3 minus 2, which is 1. And our numerator in the y is 18 divided by 2. So we can keep simplifying this. We have 1/2, and 18 divided by 2 is 9. Now we can graph it to find out for sure, but that's what we get using algebra. And I hope I'm sure. I'm sure someone will correct me if I'm wrong. Okay, now I believe some classes we had time to do this. So we took these 2 coordinates, the 2 x values, added them. Oh, excuse me, must have held my fist too far down. That creates our x coordinate, and adding these 2 creates our y coordinate. Add them and then divide by 2. So as we do a little math, we have -0.6 divided by 2. And here we have 2.9 divided by 2. Wait, I did that wrong. 2.5 plus 4 is 6.5. So half of this would be -0.3. And half of 6.5 is, let me just double check on my calculator. 6.5 divided by 2. Yep, 3.25. Final answer. So can I do this with fractions? And the idea is absolutely. You could turn these into decimals and work with them, or you could turn them into, you could just add fractions. You're like, ooh, adding fractions. So we add the first two x values, and we add the two y values. And don't forget, right, we have to divide by 2. Ooh, so it's probably been a long time since you've done this, but adding mixed numbers, this is very hard to do. So it's probably easier to turn this into a decimal. 4.3 repeating, take away 2.15 is 2.2. 2 and 1/5 is 2.2. And then I want to divide by 2. So 4.3 repeating, take away 2.2. We get 2.13 repeating, divide by 2. And we get 1.0. I'm just going to round to 1.1. Now let's look at this other number. 1/6 is 0.16 repeating. So this is 3.16 repeating plus 2/3 is 0.6. So this is 3.6 repeating. If we add those together, and divide by 2, we get 6.83 repeating. Divide by 2. I do have a calculator off to the side here, and we get I'm just going to round that to 4. So this would provide an approximate coordinate, even though we're dealing with fractions. Okay? Nice work. Now let's take a look at a soccer game. It says Cameron, Jamie, and Arthur are all playing soccer. Their locations are recorded by a motion tracking system. The distance between the grids is 5. So each grid is worth 5 meters. Okay, so we notice 5, 10, 15, 20. Okay. How far apart are Arthur and Jamie? So we're going to draw a straight line between Arthur and Jamie. And we're going to use Katrina's formula to figure out their distances, right? So to figure out their distance, we see that there is a Pythagorean right triangle here. We notice this is 3 and this is 5. Okay. So if that's 3 and that's 5, this distance, the distance between Arthur and Jamie has to be 3 squared plus 5 squared. And take the square root. So the square root of 34 is 5.83. So it's approximate though, I'm approximating. So that's how far. It says round to the nearest tenth. Okay, so I'm going to 5.8 meters. But hold on a minute. This isn't actually 3. Each blocks is 5. So I need to multiply that by 5 because each distance is 5. So I'll take my answer and multiply by 5. And I get 29.2 meters. Okay, then it says, who is closer? Cameron. Who is closer to Cameron? So it seems pretty obvious just by looking that Jamie is much closer to Cameron. Jamie is closer to Cameron. But it says to explain, and I can't just go by looking. Poops. Okay, so that means that I have to figure out this distance and this distance. So this distance looks like I went 4 and I went 4. So this is the square root of 4 squared plus 4 squared. So what would that be? The square root of 32 And we're going to multiply by 5, right? Because each box is 5. So they are 28 meters apart-ish. Now let's see how far is Arthur and Cameron. So if we look here, to get from Arthur to Cameron, we go up 1, but then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So this distance is 1 squared and 9 squared, and take the square root. So what is the square root of 82? Yeah, much further away. I'm going to multiply by 5, and we get 45.3 meters. So now we can give our answer. Jamie is closer to Cameron because Jamie is 28 meters away, and Arthur is 45.3 meters away. So I'm not just going by looks like, I can prove it. Now, last question, it says the soccer ball is located at point 3560. Who's closer to the soccer ball? 3560. So let's give ourselves some more room to work. 3560. All right, so here's the soccer ball. Definitely looks like Arthur is closer. And we can compare, and I don't know if you notice it, but if whoever's the greatest, if we multiply any number by 5, then that would still be the greatest, whatever the greatest is. So, but we're going to try to find the closest. So we see a triangle here, 3 and 5. We see a triangle here, 2 and 1, 2, 3, 4, 5, 6, 7, 8. And we see a triangle here, 4 and 1, 2, 3, 4, 5, 6. So we can find each of these dimensions, right? This distance has to be the square root of 5 squared plus 3 squared, and take the square root. This distance has to be the square root of 2 squared plus 8 squared, and take the square root. And this distance between the soccer ball and Cameron has to be the square root of 6 squared plus 4 squared, and take the square root. So we're going to do all those calculations in order to solve and figure out. So the distance between the soccer ball and Arthur is this. The distance between the soccer ball and Jamie is this. And the distance between the soccer ball and Cameron is, so whoever's shortest is closest. Okay. So who's the closest? Definitely it looks like Arthur. Arthur is closest because he's the shortest distance away. Nice work, guys. See you next time.